In lesson 5.6, you're going to be graphing inequalities in two variables. So you'll graph inequalities on the coordinate plane, and you'll solve inequalities by graphing. You have a few vocabulary words. First of all, an equation defines a boundary which divides the coordinate plane into two half planes. So here you have an image right here. Here's the boundary. You have a half plane in this direction, and you have a half plane in this direction. Next, it says the boundary may or may not be included in the solution. So when it is included, the solution is called a closed half plane. And when it's not included, the solution is called an open half plane. Key concept here, when you are graphing linear inequalities, step number 1 is to graph the boundary, just using the strategies we've learned before, making a t-table, using slope-intercept, using point-slope. And when you are going to connect those points, you're going to use a solid line for less than or equal to or greater than or equal to, or a dashed line for less than or greater than. Then you're going to use a test point to determine which half plane should be shaded. If the point 0, 0 is open, I always use that point because it's easy to work with zeros. Otherwise, find another point that you can use, and then you're going to shade in the direction that has the solution. So let's look at some examples. For example 1, we're going to start by solving for y in terms of x. So we have it in slope-intercept form. And so we are going to go down 2 and put a dot. The slope is up 3 over 1, put a dot. You can continue that as much as you want. Take note of the inequality symbol. Because it's a greater than, we're going to connect it with a dotted line. Okay, just my preference, I'd like to choose the point 0, 0 if it's open. So I can plug in 0 for x and 0 for y. And what we have is 0 is greater than 3 times 0, which is 0 minus 2. And that is a true statement, so I'm going to shade in that direction. Let's take a look at a couple example problems. In 1a, we already have y in terms of x, so I can go up 3 and put the y-intercept at 3. The slope is 1/2, so I can go down 1 to the right 2, or I can go up 1 to the left 2. It is a greater than symbol, so I'm going to connect those points with a dotted line. And I'm going to pick the point 0, 0 to plug in for x and y. 0 is 1/2 of x plus 3. Is 0 greater than 3? No, that's not a true statement, so I will not shade in the direction of 0, 0, but I'll shade up here above the boundary line. 1b, I can rewrite that as y is less than x minus 1, and when I have a coordinate plane at -1 is where I'll put my y-intercept, and my slope is up 1 over 1. And so I'm going to connect that with a dotted line because it is a less than symbol. Remember, in order for it to be a solid line, we would need to have that or equal to sign underneath. And once I'm done, I'm going to pick a point. I always choose 0, 0 if it's not on the line. 0 is less than 0 minus 1. That is not a true statement, so I'm not going to shade in that direction. I'm going to shade downward. So just to review, when you're graphing linear inequalities, first of all, you're going to graph that boundary line, connect it with a dashed line or a solid line. Then you're going to do a test point to see which half section or half plane should be shaded, and then shade that part of the graph to indicate the solution. In example 2, we have graphing an inequality using less than or equal to or greater than or equal to. Still same first step, to solve for y in terms of x, and then graph that equation on the line. And because it is a less than or equal to sign, you're going to connect those points with a solid line. Then you're going to test using a point. I mentioned that I like to use the point 0, 0. Really, I like to use any point that has the same x and y value, so 2, 2 or 3, 3, just so that I don't get confused when I substitute those points back in. But if that statement is true, then that's the direction you're going to shade. If it's false, you shade in the other direction. There's a study tip right there that when selecting a test point, a standard choice is often the origin, like I said, because it often offers easy calculation. But if 0, 0 is on the border, you have to choose another point that's not on a border. So for example 2, the guided practice problems, we're going to start by writing y in terms of x. Now we could just substitute points in here and make a t-table. For example, if I did x and I did y, I could do 7. 7 minus 8 is less than or equal to 3. We could also choose the point 9, and 9 minus 11 is less than or equal to 3. Or we can write it in terms of x by saying x minus y is less than or equal to 3. Subtract x, negative y is less than or equal to negative x plus 3. And when we divide by a negative 1, we get y is greater than or equal to x minus 3. A couple things to pay attention to. Since we divided by a negative here, the inequality sign flips. A negative divided by a negative is a positive, and we also have to take the 3 divided by negative 1 as well. When I graph that, the y-intercept is negative 3, 1, 2, 3, put a dot. Slope is 1, 1, so up 1 over 1, up 1 over 1. Since it's a greater than or equal to sign, I'm going to connect those points with a solid line, and then I'm going to choose a point. I'm going to choose 0, 0. Is 0 greater than or equal to 0 minus 3? Yes, it is, so I'm going to shade in that direction. For 2b, we can, again, write y in terms of x, or we can use a strategy called finding the x and y intercepts. So we know that that's a good method when both coefficients of x and y are factors of the other number. So if x was 0, y would be 6, and if y was 0, x would be 9. So I have my 2 points that I can graph, 0, 6, and then 9, 0. And then I'm going to connect those with a solid line because it's greater than or equal to. And you might just wonder if greater than or equal to would work just to shade above the line, and that is true. We'll double check by picking a point, testing a point. 0 times x, 0 times 2, and 0 times 3 is 0, and 0 is greater than or equal to 18. That's not true. And since it's not true, I'm not going to shade in that direction. I'm going to shade in the opposite direction. Finally, in example 3, we're going to solve inequalities from graphs. And so it says to use a graph to solve this inequality. Same steps. First graph the boundary. Then in this case we have x equals 3. Remember that at x equals it's going to be a vertical line. A y equals is going to be a horizontal line. We're still going to connect those points with a dotted line or a dashed line. Step 2 is to pick a boundary or pick a point, and chose 0, 0 as a test point, and if it makes it a true statement, then shade in that direction. And since that statement was true when you substituted in 0, 0, then we're shading to the left. For 3a at the bottom, we have 4x minus 3 greater than or equal to 17, plus 3, 4x is greater than or equal to 20, divide by 4, x is greater than or equal to 5. That's going to be a solid line, 1, 2, 3, 4, 5 at 5, and we'll pick the point 0, 0 to plug back in. 4 times 0 is 0, 0 minus 3 is negative 3. Negative 3 is not greater than or equal to 17, so since this direction does not work, I'm going to shade in the opposite direction. For 3b, I know the answer is shown there, but if we subtract 6, we get negative 2x is greater than 6. And when we divide by a negative, we're going to flip that inequality sign and get x is less than -3. So that's going to be a vertical line at x is less than 3. It actually should be a dotted line because it's just a less than symbol. And to pick our test point, we'll do 0, 0. 0 times -2 is 0. 0 plus 6 is greater than 12. 6 is not greater than 12, so I'm not going to shade to the right. I'm going to shade to the left. For example 4, we're going to be taking a story problem and translating that into inequalities. So just using our skills from previous lessons to translate that, and then using our new skill of graphing an inequality on a coordinate plane, and then seeing how that ends up. Make sure you look through that example and become familiar with how you translate a story problem into an inequality and then graph it. For number 4, guided practice, Neil wants to run a marathon at a pace of at least 6 miles per hour. It says write and graph an inequality for the miles he will run in X hours. So if he wants to run at 6 miles per hour, 6 times x is going to be our translation there, and we want y to be greater than or equal to that. In order to graph that, we have a y-intercept of 0, 0. Obviously, if he runs 0 miles, his pace is 0 miles per hour. But if I graph the next point, up 6 over 1, we have one more point that we can connect with a solid line. And notice on this one, 0, 0 is on our graph, so we can't use that as our test point. But I could pick the point 2, 2. So 2 for x, 2 for y. Is 2 greater than or equal to 6 times 2, 12? No. So this point right here does not work, so I'm going to shade in the opposite direction, or in the upward motion. Finally, let's take a look at some of the higher order thinking skills problems. On page 321, we have an error analysis. Rico and Kristen are solving for y is less than or equal to 8/3 x by graphing. Is either of them correct? And explain your reasoning. Well, first of all, we might want to write y in terms of x, and so we need to isolate the y by dividing by 4. So when you're dividing by 4, you're actually multiplying by 1/4, so the 4's cancel out, and multiplying by 1/4. So what we get there is y is less than or equal to 8/12 x, or y is less than or equal to 4/6, or y is less than 2/3 x. So the y-intercept is 0, 0. Both Rico and Kristen have 0, 0 on their graph. The slope is 2/3, up 2 over 3, up 2 over 3. They both have solid lines, which is what they need, so they'll both check out there. And then finally, we need a test point to see which way to shade on our boundary line. So it looks like Rico chose the test point 1, 1. And 4 times 1 is 4, and 4 is less than or equal to 8/3 x. 4/3 is less than or equal to 8/3. 8/3 times 1. 8/3 times 1 is 2 and 2/3. 1, 1 does not make that statement true, so he did not shade in that direction. He shaded in the opposite direction. So Rico is right. Let's go check Kristen. Kristen chose the test point 0, 0, which was her error. If 0, 0 lies on the boundary line, you may not choose it as a test point. Just a few things to remember from this lesson. We are graphing linear inequalities with 2 variables. So once we have the x and the y, we have lines that we can graph on a coordinate plane. In this case, we're going to be dealing with solid lines and dotted lines. The solid lines translate to less than or equal to and greater than or equal to, and the dotted are less than and greater than. We're also going to be shading above the line or below the line based upon that test point that we choose. You can choose any point you want, but I choose 0, 0 if it's not on the boundary line, or points that have the same x and same y values, so you're not getting confused on what to plug in for each variable. So hopefully that makes sense after you try a few practice problems and watch the Edpuzzle video.